So let's start with this custom volume plugins thing. What I am trying to do is show you some examples about some work that I did and some work that other people do about how to use plugins, like what's a plugin, how to use them, and how to create them is the important bit of this talk. So if you want to open the door and just go out now, I just want you to know one thing. It's extremely easy to do this. I mean, you usually get really scared about working with a project like Kubernetes. They have millions of lines of code. People from Google is working there, people from Red Hat, OpenStack, whatever. Sorry. So these people is not better than you. You can get this code and just start working on it, and you are going to do really awesome things. So going back here. Yeah. So I was working a plugin with the guys from GetStack, which is for Flocker. I don't know if you know Flocker. Flocker is basically some kind of volume plugin started for Docker and then moved to Kubernetes. And when these guys came to me and said, like, can you do this plugin? I said, like, of course, it's open source, it's Kubernetes, it's awesome. So I will share some of my knowledge. What's a volume in the Kubernetes world? So it's like an abstraction that they do for having some data in your container. What's the problem that you usually have with containers, with Docker containers? At least for me, the first time that I started a Docker container, I started and ran some commands inside it, and then I closed it, and I lost everything. And that's kind of normal, I think. So Kubernetes came with the thing, which is this volume abstraction, and they have this way of storing some data inside your cluster. There are two kinds of volumes here, which is persistent and non-persistent. The main difference is that a persistent volume is a volume that your operations team is going to put in your cluster, and you can just claim it. Yeah, imagine that you have your your huge Kubernetes cluster running on Raspberry Pis, and you have a bunch of pen drives as well around the house. So this is going to be a persistent volume for you. Yes, put the volume plugins there, and you say, like, okay, we have some persistent data here. You can use it. You can claim it. And the non-persistent data is going to reside in your cluster as well. The lifetime of this non-persistent is going to be within your pod. So you know the difference between a pod and a container. A pod can have several containers inside. If one of these containers goes down, your pod is still going to have this data. But if all the pods goes down, you're not going to have this data. You are going to lose it, and it's not going to be anywhere else. So from the user point of view, it's really easy to use a volume. This is a spec of a pod in this case. Sorry. So if you see here, you are defining a volume. In this case, we are using Flocker volume, but this can be a secret, or can be a Git repo, or an empty host, or whatever plugins we are going to see that are supported in Kubernetes at the moment. And where you want to mount it, you say it on the spec, like this container, the engines, is going to have access to this WW root that you are defining here. Let's see it here more, you see? So you are going to have a Flocker volume mounted in some place in your cluster, within your pod, and you can access to it on this mount path. So this is some of the volume plugins that are supported at the moment at Kubernetes. Like the normal ones, like Elastic Block Storage and Persistent Dix on GC. The guys from Red Hat made the GlusterFS, guys from OpenStack, Cinder. You have NFS, you have a Git repo, which is basically cloning a repo into a host, and you can access to it. You can even get the revision that you want. And Flocker, that itself is going to have like some other backend supported by it. And you have secrets. So the secrets that Kelsey was talking before is finally a volume that is mounted on RAM, and you can access to it. So is this new? Sorry. It isn't really. I mean, Docker already have something for volume plugins and network plugins. There is a little bit of difference between how Docker tries to do the plugins and how Kubernetes is trying to do the plugins. So in the case of Docker, you have an HTTP API. You can say to the HTTP API, like, OK, I want to create this volume, I want to mount this volume in some other place, unmount it, like typical things that you can do with the volume on Linux. So this is basically it. If you want to implement a plugin for Docker, you just need to implement an API that supports these 5 endpoints, or it was like that like 2 or 3 months ago. Don't know if they changed it, I don't think so. It says where is it mounted in your host, and how to mount it and how to create it, and the other way around, how to remove it and how to mount it. In Kubernetes, it's completely different. Kubernetes, if you do a plugin, you need to introduce your code into the Kubernetes code base. So it's, I don't know if you are familiarized with Go. How many people do Go here? Cool. So you know what an interface is. It's basically like a Java interface, but you don't need to say that you are implementing it. If your struct have the methods that implement this interface, it's just implementing it. You don't need to be explicit about it. So this is how they do how they do the plugins in Kubernetes. Basically, you just need to implement few methods and few structs, and you are going to have your plugin up and running. Is it better or is it worse than the HTTP API? I don't really know. I think that they are different. Well, this is nice as well because getting into the Kubernetes code base is going to give you some advantages like the pull request review, which is extremely good. So let's go to some code now. This was the introduction. I don't know if you have some questions. I can ask, I can reply to some questions later about this introduction. But now we are going to see the important bit of the custom volume plugins, that is like, how can I do mine? There are just few steps. There are just 5 steps. I said at the beginning, this is really easy to do. One of the things is like when you have a YAML, this YAML definition needs to be somewhere. In this case, they are using this. So if you remember the YAML at the beginning, I was using Flocker, which was a key in the volumes. This is where you say like, OK, my YAML is going to have a key, which in this case is called Flocker. In the case of NTD, it's called this. And in the case of the Git repo, it's called Git, whatever. If George wants to do one, it's going to be called George his key. And that's it. I mean, but there are 2 places where you need to do this. One is the normal definition, like the global one. And the other one is for the version that you are trying to implement, that at this moment is just version 1. Cool. So since we have this, we have already a way to tell the kubelet, OK, I want to use this volume. But what's this volume? Now we need to define it. We say like, OK, there is a huge bunch of lists. I'm just showing you 3 lines here. But there are something like 20 different lines here. It's saying, please load this volume for me. In this case, I'm showing you MTD and Git repo. I'm changing the examples because it's extremely standard. Sorry. It's extremely standard. Like all the plugins are done the same way. So I say, this, if you see, is on the kubelet. You say like all the available plugins for the kubelet that you are running, or that you are going to run. And this is the interfaces that I was mentioning. There are 2. One is the volume plugin, and the other is the builder. So what you need to know from here, we're going to see some examples later. Yeah. We need to know from here is that init is like a package on Go. It's just going to be called once. And it's never going to be called again. It's just going to run for the first time. Name is the name that you want to give to the plugin. Usually they have some reserved word, which is Kubernetes.io. I didn't know that when we made the Flocker plugin. So our Flocker plugin is called Kubernetes.io/Flocker. Don't do that. And what can support your plugin? This case is usually used to say if your plugin is a persistent volume or is just a volume. But on the spec, you can define more things. So it's just a Boolean. Like, you send the spec and say, like, okay, do you support this, true or false? No more than that. So NewBuilder and NewCleaner are like, let's call it factories in Java. Are like a wrapping of telling Kubernetes how they are going to create this volume and how they are going to clean the volume. Like what you are going to return is an struct that is able to create plugins and to clean the plugins. See, you are returning a builder and you are returning a cleaner, and of course, like in Go always, you return the error. Cool. So this is for Flocker. One example. I will show you Git repo later. This is pretty simple because, as I told you, you are just returning a wrapper to create new things. So you are returning a Flocker builder. So like, okay, this is going to be like a Flocker plugin, and this source.dataset name is the dataset name that you were sending on the API definition that we were mentioning before. So this is an input from the user, actually, on the YAML file. And we need to implement the builder. So the builder itself implements volume. Volume is just going to return some methods that it needs, but there are like 2 of them, pretty simple. But here is where the magic happens, this setup and SetUpAt. So FS group is, I don't know you, but when I install Apache for the first time, one of the problems that you usually have is that your web application doesn't really belong to the user that is running Apache, so you cannot see the webs. This is mainly trying to fix it. Like FS group is the group owner of the files that will have access from the kubelet. Setup in some of the samples that I'm going to show and some of the code that is on Kubernetes is usually just calling SetUpAt. SetUpAt is the same than setup, but you are providing a string where you are mounting the file. So this is used for mounting and attaching. And finally, the get attributes is like giving simple stuff about the volume, like is it read only, or was it there before? Oh, sorry. Well, what? Cool. So I'm going to show you some example now about Git repo, how they do this setup thing, which is really the important thing for your plugin, the important bit. So it's not really simplified. This is why I lie. It's a little bit more difficult, but it's really few steps that you need to follow completely synchronous. I mean, it's Go. If you want to use channels, if you want to use Go routines or things like that, you can do it, but usually it's just A, B, C, D. That's it. So this is for Git repo. You cannot see anything. I was not expecting you to see anything here. This piece of code is just doing this. So remember, we are using the Git repo. The definition of a Git repo is what's the repo that you want to clone and what's the revision that you want to check out. So one of the things that's happening on setup is not like init. So it can be called several times during the life of your kubelet. So you need to say a way of having some kind of mutex there. So like, okay, I already ran setup. Don't run it again because you are going to create a new volume or you are going to load some other stuff that I don't care about. So there is something called metadir, and you can just touch a file there and say like, okay, touch this file metadir. This means that my volume is already ready for using. In the case of Git clone, it's grabbing another plugin for preparing the path. So it's grabbing empty path. I'm going to show you later that one. The only thing that empty path does is creating a host dir for you, sometimes on temp file system like secrets, and sometimes like a proper one. You clone the repo, you check out the revision that you want, and job done. You mark it as ready, so the next time that you go to setup, you are not going to have the problem that you had in the past. Sorry, not the problem. You are not going to run setup again because it was ready already. So this is the bit that I was telling you about entity. It's just few lines in the top and few lines in the bottom. This is the important bit. It's like, okay, it's memory or is default. If it's memory, it's a setup 10 file system. If it's not, it goes to the normal one or fail. Okay, now I'm going to show you an example for Flocker. How we did this. Simplify example. And there is not such a thing like simplify for this. Yeah, I like this GIF. Cool. It's pretty small. It's doing a lot of more stuff, but all of this stuff is really done by the Flocker client. And in case of Git, if you were using a Git client, probably the previous client that I was showing you was going to be much more easy and much more smaller here. Basically, what this is doing, sorry. Again, I don't expect you to read this. I will show you an example, a link to the example later. So we see the same struct. It's like, was it called already? Is it ready? And at the end, we are going to mark it as ready. So if the dataset is ready, good, I'm going to use it. If it's not ready, I don't really care. I will just raise an error and say like, okay, this is a persistent volume, so please create the volume before you try to access it. This is an internal thing of Flocker. It's like, okay, if the primary UIDs doesn't match, it means that it was a rescheduled pod, so it was in other place, and now it's coming here, and the Flocker agent mounted, but doesn't really match. So this is really internal Flocker things that you don't care for doing plugins, and you wait until it's ready. Cool. And finally, you have the persistent volume plugin. Persistent volume plugin just have one method, a part of the volume plugin methods, which is the access modes. It's an array of structures of volume access modes. Like if it's real, like for example, this is for AWS. What are the things that you can do with this persistent volume? Like if it's read write, if it's just read, or etc. Some kind of a spec for the persistent volume. This is just needed, of course, if you are doing a persistent volume plugin and not just a volume plugin. So this is the whole example that I was showing you before with Flocker. I was doing it with the guys of JetStack and the guys from Cluster HQ. If you want to take a look to the URL. So this is basically the pull request on the Kubernetes code base. And you are going to see that we have some problems with the comments. Not really problems. They were like valid comments, but we need to fix them, of course. Yeah. So there are a few trends in a container world conference. You always need to show a boat that is sinking. You always need to talk about Kelsey Hightower. In this case, we had it upstairs. And I think that's it. No, do we need some else? No. So this is basically the RENAI. I'm pretty sure that any of us here knows a lot about the history of boats and boat sinking and all that. So what I'm trying to explain is the problems that are not really problems. This is why they are in quotes that we have. We were doing the Flocker volume plugin. We had a tough deadline, so we were working from here from London, and these people was working on the US, and we have some time zone problems as well for trying to meet them. So one of the problems is CLAs. I don't know if this is going to be fixed now with the Cloud Native Compute Foundation or things like that. So perhaps you can just sign one and work with it. So thanks to the CLAs, I was working with Matt from JetStack a lot, and he couldn't push any code because I was the only one that was signing for this. And I mean, he was signing for it, but it wasn't working. We don't know why, but we don't care. We just need to tough deadline. We need this live. Shippable and Jenkins. I don't think that this is just Kubernetes. This happens everywhere. You have a lot of false positives, and this is always breaking. And this was happening in Kubernetes as well. Jenkins was working kind of cool, but shippable was always failing. I don't know if they are still using it, but probably this is fixed already. I'm talking like 4 months ago or something. So I'm pretty sure that it did something. And there are a bunch of hack scripts. These hack scripts are used for things like adding a header to the documentation to know the revision where you are. And sometimes they fail because they check the diffs to see if you changed the code, but you didn't change the documentation and things like that. And it's just a shell script, so sometimes it was just failing. And if this fails, you have like a red bubble, and you're not going live. And the pull request. This is not really a problem. I mean, I learned a lot with the pull request comments of these guys. But you need to know that you are going to have a lot of comments. There are a lot of people working Kubernetes, and there are a lot of people that knows far much more than you, and they're going to say, you are mistaken here. You say, no, no, I am not mistaken. I'm never mistaken. No, you are not right. So this is really helpful, but it will take a lot of time. And more, again, if you are in London and you are working with US people. So summarizing this, creating a volume plugin is extremely easy. You need to add the API, which is the way like your users are going to interact with the plugin itself on the YAML file. You need to add it to the kubelet command. Just enable it. This is just a list of arrays. I mean, the point 1 and point 2 are not rocket science at all. And you need to implement volume interfaces like NewBuilder. The important bits on the volume plugin interface is NewBuilder and NewCleaner. And you need to implement the builder interface, the builder itself. And the important bit there is SetUpAt, which is really the one that have the logic to know how do you set up this. How do you set up this plugin to use it? It's pretty important. For example, we had one problem with Flocker, which was that we were trying to be really clever with SetUpAt, and we were trying to create the volumes at setup time. You cannot do that. I mean, it doesn't make any sense. After I explain you like what's a volume and what's a persistent volume, it doesn't make any sense to create the volumes at this time. And in case that is persistent, you need to implement the persisting interface as well. And that's it. Job done. You don't need anything else. You need a lot of time for fixing pull request comments, and that's it. So one more thing. You were not expecting this one. So this is my office, Job and Talent. We were trying to find jobs to nice people around the globe, the perfect job for them. So we have some machine learning with the Scala. We have some Go, Ruby on Rails. We are trying to schedule some things as well. So if you want to see Travolta, no, Travolta's not working there. We are hiring. We are hiring there. So let me know later. There's a bunch of guys working with me as well. And thanks.
Thank you, Alex. Any questions? Yes.
It's always that. Hi, you'd mentioned that you were finding it difficult to create volumes at the setup stage. I was just wondering what the issues were.
No, I didn't find difficult, but it was not allowed because you need to create the volumes before. Like, for example, in the case of Flocker itself have an agent that is living within your pod, and you need to create the volume before being able to use it. And we were trying to do that on the SetUpAt, and you cannot really do that. No. It's by architecture of how Kubernetes work. One of the comments by Tim, I think that was actually was one of the heads of Kubernetes, and he said that this is not doable there. It's not the place for it. I think that actually on Kubernetes 1.2, they have a new interface that is going to allow people to create volumes, but I'm not pretty sure about that. That was the plan 3 months ago. I'm pretty sure that it continued being the plan. It was not a technical issue. It was just, this is not the place for doing it.
Other questions? Yeah. Okay.
Yeah, that's really a good point, because I would expect that there are some people around there that is going to have a volume plugin that they don't want to share with the world as well. In that case, I think that it's going to be, it would be really great if you have some kind of a standard way like Docker has with this HTTP API, but you do these HTTP calls in a plugin. So imagine that you can create HTTP volume plugin that is not really doing anything. It's expecting an external HTTP server to do this for him. So I think that this is doable. I mean, probably we need to investigate it more, but I think that just providing this in an HTTP API way and calling it from the volume plugin, we can ask the guys from Kubernetes later. And actually, I'm surprised that they don't have anything like that. But I think that it's still doable if they accept this HTTP volume plugin, that I don't know if they will.
Okay, other questions? Yes. Can you repeat the question for the...
Oh, sorry.
It's more of a, there is a proposal for a flex volume plugin, I guess 18333, that would...
For doing that? Okay, cool.
Yeah, so you could create one based on what's needed without having to check it into Kubernetes. You said 18333.
Cool. Thank you. Other questions or answers? Go on. Take my mic, please. Go on.
Yeah, so I was wondering, in case you have any secrets that you need to set up the volume, like with the Git repo, if you have an SSH key, how would you handle that? Or how does that feed into the setup process you described?
I think that there is actually an SSH volume plugin for that. But all these kind of things, I think that they should live in a secrets volume.
So when you have the secret, you need the secret to set up your volume, or to mount it.
Yeah, but you can have more than one volume as well. So you can have.
They communicate with each other.
Oh, okay, I know what you mean. Like race condition, like when is it going to be ready? I don't know. I don't know. Perhaps somebody knows. It would be nice actually to know it.
Can anyone else answer that question? Because I can't. Any other questions then in the absence of that answer? Okay, well, thank you very much, Alex.
No problem.